GATE 2017 Civil Engineering Set 1 Question 53. The spherical grid particles having a radius of 0.01 mm and a specific gravity of 3 need to be separated in a settling chamber. It is given that the value of G is 9.81 meter per second square. The density of the liquid in the settling chamber is 1000 kg per meter cube, and the kinematic viscosity of the liquid in the settling chamber is 10 raised to the power -6 meter square per second. Assuming laminar conditions, the settling velocity needs to be found in millimeter per second rounded off to one decimal place. The relevant NPTEL reference has been mentioned. So, to find the settling velocity of a particle during the sedimentation process, we use the Stokes law. As per the Stokes law, the settling velocity is given by GD square divided by 18 times of gamma into G minus 1. Here, G is the acceleration due to gravity of the body in meter per second square. D is the diameter of the settling particle in units of meter. Capital G will be the specific gravity of the particle, and gamma is the kinematic viscosity of the particle in units of meter square per second. In this case, we have been given the radius of the particle, that is 0.01 millimeter. Using this, we can find the diameter, that will be 2 times the radius, which is 0.02 millimeter. The density of the liquid is given as 1000 kilograms per meter cube, which is present in the tank. Small g, acceleration due to gravity, is given as 9.81 meter per second square, and the specific gravity of the particle is given as 3. The settling velocity is given by GD square by 18 times of gamma into G minus 1. Gamma is the kinematic viscosity of the particle, which is given by 10 to the power minus 6 meter square per second. Substituting the values of G as 9.81, D, which would be 0.02, and converting this to the units of meter by using the factor of 10 to the power minus 3 whole square into G minus 1 divided by 18 into gamma, that is 10 to the power minus 6. The value is obtained as 4.36 into 10 to the power minus 4 meter per second. Since the question instructs to find the value in millimeter per second, we will operate this with 10 cube. This would give the final value as 0.436 millimeters per second. Since the question also instructs to round it off to one decimal place, we can round it off to 0.4 millimeter per second. So the settling velocity of the particle in laminar conditions was found out as 0.4 millimeter per second. The relevant NPTEL reference has been cited.